Good day, everyone, and you are welcome to today's session. So in today's lesson, we want to look at the graduate record examination, the GRE, the quantitative reasoning test, right? It's reasoning. Yeah, so we want to look at the GRE quantitative reasoning test. We want to have a tutorial session this day and look at how some of the questions look like and how to approach them, how to solve them correctly. Now, on the GRE quantitative test, during the exams day, you will see 4 forms of mathematics over there. So you get some questions on algebra, and then you get some questions on geometry, and then I think there is some data analysis questions that you will also answer. Here you will be given some data, and then you make inferences from it. And I think there is what we call the quantity comparison questions. So here you are given 2 quantities, and then your job is to compare in order to arrive at a solution. So basically the quantitative test comprises these forms of mathematics, or these types of mathematics: algebra, geometry, data analysis, and then the quantity comparisons. Alright, so get your paper and then your pen, and let's start solving some of the questions. Alright, so in this question, the first question we have before us, we have 2 quantities, that is quantity A and then quantity B. Now we are going to analyze each quantity and see if we can find any relationship between the 2 quantities. So let's first look at quantity A. Now quantity A says that the least prime number that is greater than 24. So here we are looking for the prime numbers that are greater than 24. However, our aim is to pick the least, the smallest of them, right? So now if you are to list the prime numbers greater than 24, of course 25 will not be a prime number, 26 will not be a prime number, 27 will also not be a prime number, same as 28. But 29 is a prime number because it has only 2 factors, that is 1 and the number 29 itself. And at this point we do not need to go on to check for the other prime numbers because we are picking the least of all the prime numbers that are greater than 24. So 29 will be the least prime number greater than 24. Hence we call our quantity A. In fact, our quantity A becomes 29. Now let's look at quantity B. Quantity B says the greatest prime number that is less than 28. So in this particular one too, we are looking at all the prime numbers that are less than 28. However, we are picking the greatest of them. So the one that is the highest of them, that is where our focus is. So let's descend from 28, we move to 27, which is not a prime number. We move to 26, which is not a prime number. 25, which is also not a prime number. 24 is not also a prime number. However, 23 is a prime number because it has only 2 factors, 1 and then 23. Now at this point, we don't have to go ahead to find the other prime numbers because we are looking for the greatest prime number that is less than 28. So the greatest prime number less than 28, here it is 23, because any other prime number we find after 23 wouldn't be the greatest, right? So now we have quantity B to be equal to 23. Now when you compare this quantity, you can clearly see that quantity A is greater because quantity A is 29 and quantity B is 23. Hence our answer is option A, where quantity A is greater. Alright, let's look at the second question. Here we also have 2 quantities that we are supposed to analyze and come out with a relationship. Quantity A says that twice Abigail's age, and then quantity B says Maria's age. Now questions like these, whenever we don't have much information or more conditions that can help us to know the ages of these individuals, we don't have any information. All that we are told is that in quantity A, it is twice Abigail's age. So here we do test. We test with numbers, right? So I can say that, okay, twice Abigail's age. So let's say, let's say X is Abigail's age. Let's say X represents Abigail's age. That is Abigail's age. Then we can say let X be equal to 4. Then twice Abigail's age is going to be 2 times 4, which is 8. That is for quantity A. Then quantity B says Marius age. So suppose Marius age is represented by y. So we can say that, let's say y is equal to, let's say 10, right? So if y is equal to 10, now when we compare these two quantities, we can see that here quantity B is greater. However, okay, so let's say that I now choose x to be, let's say, 15. If my x now is 15, then quantity A now becomes 2 multiplying 15, and that will be what? 30. And in this scenario, in this second scenario, you can see that quantity A is greater. In the first scenario where we chose Abigail's age to be 4, we realized that quantity B was greater. When we change Abigail's age and we make it 15, we now realize that quantity A is actually greater. In a situation where we have two scenarios, and then you realize that in those two scenarios, maybe in the first scenario, quantity A is greater than quantity B. And then in the second scenario, quantity B is greater than quantity A. When you have these things happening, then it tells you that the relationship cannot be determined from the information given. So always your answer will be option D. Alright, let's move on to the next question. Now in question 3, we are also given two quantities, quantity A and then quantity B. And then quantity A, we have 54% of 360. Of course, we can write this as fractions, so 54 over 100 being multiplied. Don't forget that in mathematics, off means we are multiplying, right, over 360. So simplifying this 0 cancels this 0. 2 goes here 5, and then goes here 18. So 54 times 18 is going to give us 972 over 5. And then 972 divided by 5 is actually 194.4. So quantity A, sorry about that. So quantity A is 194.4. And quantity B was given as what? 150. So now when we compare these two values, which one is greater? Clearly you can see that 194.4 is greater than 150. Hence we can conclude that quantity A is actually greater. So we choose the first option as our correct answer, where it says quantity A is greater. So I want you to pause the video and then answer this particular question, question 4. Try it on your own, and then you come back to the video to compare your answer. Alright, so I believe that by now you've tried this on your own. So let's solve it to see. Now we are given that y is equal to 2x squared plus 7x minus 3. Right, this is a quadratic equation. Now quantity A says x, quantity B says what? Y. We are supposed to compare x and y and see if we can form any relationship between these two variables. Now look at y. Y is 2x squared plus 7x minus 3. So you can see that y involves the squaring of x, right? From this particular term, 2x squared, you can see that y involves the squaring of x. Hence, generally, we can say that y will grow faster than x because of this quadratic term. However, let us not be quick to conclude. Let us not be quick to conclude that because y involves this term, it involves the squaring of x, then y generally grows faster than x. So we will say that y is greater than x, hence quantity B is greater. No. Let us test with numbers. So here, let us test with x equals 0. If x is equal to 0, then y is equal to 2 multiplying 0 squared plus 7 times 0 minus 3. And of course, this is going to be negative 3. So in this first case, in this particular case, we have x being 0, y being negative 3. When we compare, we realize that x is greater than y. Right? We can see. Hence, we can say that quantity A is greater. Now, in a second scenario, we want to test with a different number. We can say let x be equal to 1. Then y is equal to 2 times 1 squared plus 7 times 1 minus 3. And this is going to be 2 plus 7 minus 3. Of course, this will be 6 because 2 plus 7 is 9. And 9 minus 3 is actually 6. So in the second scenario, we can see that y is greater than x because y is 6 and then x is 1. Now here we will say that quantity B is greater. Can you see something being played here? I told you during question 3 or 2 that when you have two scenarios where in the first instance quantity A is greater than B, and in the second scenario quantity B is greater than A, clearly the relationship cannot be determined. We must have one thing running throughout, being constant in what we are testing. So because of these situations, we can confidently say that the relationship cannot be determined from the information given. Hence, our correct option is option D. Alright, let's look at the next question. Now we have question 5. Now here we are given two quantities to analyze. Now in these questions are under indices, right? Now questions under indices, I have a way I solve them. So let me take you through. Now I write quantity A first, which is 2 to the power 30 minus 2 to the power 29 over 2. Now I don't know the relationship, I'll just put a question mark there, and then quantity B is 2 to the power 28. What I'm going to do is I'll try and break quantity A down, right, and see if there is any relationship between the left side and the right side, which is quantity A and then quantity B. Now from indices, you remember from basic algebra, A to the power m multiplying A to the power n. When the bases are the same, we can have A to the power m plus n. I'm going to employ this in the quantity A. Now the 2 to the power 30 can be written as 2 multiplying 2 to the power 29, because at the end of the day the bases are the same. When I add, I'll get 2 to the power 1 plus 29, which is 30. So minus 2 to the power 29 divided by 2. Don't forget to be bringing your question mark, right? We are trying to compare something. Now I can factor, in fact there's no need to factor. You can see that 2 times 2 to the power 29 minus 2 to the power 29 is just 2 to the power 29. I believe you can see, divided by 2, right? Because here we have 2 of these and you are subtracting 1 from the 2 of these, and definitely you are going to be left with 1. Now when I get to this point, I can multiply through by 2. So if I multiply through by 2, I have 2 to the power 29 over 2 multiplying 2 to the power 28. Clearly this cancels this, so we have 2 to the power 29. And then with this one, can you see from this particular rule, the bases are the same. So this is going to be 2 to the power 1 plus 28, of which we are going to get, so let me come here, of which we are going to get 2 to the power 29, then 2 to the power 29. Now what relationship can you see? They are equal, right? You can see that these two are equal. Hence, we can choose option C, the two quantities are equal. So this is just basic indices. You have to try to break one of the quantities down to see if there is any relationship between the two. And upon breaking quantity A down, we arrived at this particular conclusion that quantity A is actually equal to quantity B. In question 6, this is not a quantity comparison question. Here, we are told that which of the following numbers is farthest from the number 1 on the number line. So let's quickly draw the number line. Let's say this is our number line. We have 0, we have 1, we have 2, we have 3 going. And then here we are going to have negative 1, negative 2, and then negative 3. Then we can have some numbers also going. Now we need to go through each of these numbers and see which one is farthest, which one is far away from 1 on the number line. Of course, clearly if I'm on 1, if I'm here, then when I'm moving to negative 10, in fact I'll be going this side till I reach negative 10, right? I'll be going to, when you check option B too, we are looking at negative 5. Of course, if I extend this line, negative 4, negative 5, let me keep on extending, negative 6, negative 7, negative 8, negative 9, we can have our negative 10 here. So clearly with the first option, I'll be going up to here, right? I'll end at where negative 10 is. Now with the second option, which is negative 5, I'll still start from here, but this time around I'll end here. Then with 0, I'll end here. With 5, I'll be going this side, right? But look at something. Of course, I can also list from here to 10. If I let me extend so that we can see the picture well. So 6, 7, 8, 9, then 10. So with 5, I'll be going up to here, this particular portion. Then with a positive 10, I'll be going up to here. But look at something. If you are counting the steps from 1 to 10, and then from 1 to negative 10, you can see that negative 10 is farthest from 1, because we move from here to here. So let's count the steps. So from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we move 11 steps if you want to move from 1 to negative 10. But let's see from 1 to 10. We have how many steps? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can clearly see that negative 10 is farthest from 1, because we move 11 steps till we get to negative 10. If this is difficult to get, you can also employ this. You can take the absolute difference. The absolute difference of each of the options. The absolute difference of the options, and then 1 to see the distance, right? So for the first option, for option A, the absolute difference of negative 10 minus 1, of course, this is going to be 11. Then for option B, we have negative 5 minus 1, which is going to be what? 6. Then for C, we have 0 minus 1, which is going to be 1. Now for D, we have 5 minus 1, which is going to be 4. Then for the last option, we have 10 minus 1, which is going to be what? 9. Now when you check these distances, clearly 11 is the highest or the longest distance. So our option will be option A. So if you don't want to use the number line, you can also calculate the absolute difference between the options and then the number 1. You can clearly see that negative 10 is farthest from 1. Now in question 7, we are given a simple linear equation, and our task here is to find the value of x. Now what is the equation? We have 5x plus 32 is equal to 4 minus 2x. You remember basic algebra, where you are told by your teacher that you group like terms, right? So here we are going to group like terms. We will send all those with x to the left side, and then the numbers to the right side. So we have 5x. Now we will move the negative 2x to this side. Of course, we have negative and it crosses the equal to sign. We get positive. So we're going to have 2x here, which is equal to, you already have 4 here. So we move 32 to the other side, and we are going to get negative 32. Now what is 5x plus 2x? That is 7x. And what is 4 minus 32? That is negative 28. Now the goal is to find the value of x. So we can divide here by 7 and then divide here by 7. So that 7 cancels this 7 and then we are left with x. And that is actually what we are looking for. So what is 28? Negative 28 divided by 7. That is negative 4. So 7 goes into 28 4 times. But because there is a negative sign there, we have negative 4. Hence the value of x is negative 4. Now let's look through the options. If you have negative 4, yes. So the first option, which is option A, is our answer. Now in this question, question 8, is that there's a problem that we want to solve. A car got 33 miles per gallon using gasoline that cost $2.95. That is $2.95 per gallon. Approximately, what was the cost in dollars of the gasoline used in driving the car 350 miles? So what we are going to do is that the car moved 33 miles per gallon. And don't forget that the cost per gallon is giving us $2.95. Right? That is the cost per the gallon. Now, what we are going to do is that we want to calculate the cost of the gasoline used in driving the car. That is 350 miles. We want to use simple ratio to find this. Of course, 33 miles is to 1 gallon, because the car, it says a car got 33 miles per gallon. So 33 miles uses what? 1 gallon. Right? Now, then the question is 350 miles will take how many? gallons. We don't know, so let's represent that by X. Then by simple ratio, we know that 33 over 1 is equal to 350 over X. We cross multiply so that we get 33 multiplying X. Then we have 350 multiplying 1, which is still 350. Now we want to find X, so we divide here by 33. We divide here by 33. And X is giving us 10.60, maybe 61. Yes, let me put it on at 4 decimal places. Now it tells us that when the car travels 350 miles, these are the gallons, the number of gallons that the car is going to use or utilize. So it's going to utilize 10.6061 gallons. However, 1 gallon costs 2.95. So the total cost in dollars is going to be 10.6061 multiplying 2.95. This is a decimal point. So 10 times 60, then 61 multiplying 2.95. Actually, the answer gives us 31.28 or 29. Let me run into the 2 decimal places. However, you can see that there is no 31 in the options we have, but approximately we are going to pick C as our answer, which is $30. Right? You know, some of the questions that comes in the GRE quantitative test, there is one method that I call the approximation method. Sometimes you can approximate the values in order to get your answer. Of course, we solved and got 31, but out of these numbers, which one is closer to 31? And of course, definitely it is 30. So we choose option C as our answer. Question 9 says that 1 pen cost 0.25, that's 25 cents, and then 1 marker costs 35 cents. Now, at those prices, what is the total cost of 18 pence and then 100 markers? So what we are going to do is that we are going to calculate the cost of buying 18 pence, right? We know that 1 pen cost how much? 0.25 cents. That is 25 cents. So the cost of 18 pence is going to be 18 multiplying 0.25. And what is 18 multiplying 0.25? That is going to be $4.5. Also, we were told that 1 marker also costs 35 cents, right? We're also given this information in the question. So we want to find the cost of 100 markers. So the cost of 100 markers will simply be the number of markers you are buying multiplied by the price of 1 marker. So it will be 100 multiplying 0.35. And what is 100 multiplying 0.35? That is going to give us 35. So the cost of buying 18 pence is $4.05. And the cost of buying 100 markers is $35. Now to get a total cost, we add each of these costs. So the total cost is simply going to be 4.5 being added to 35. And what is 4.5 being added to 35? That is going to be 39.5. So the total cost of purchasing 18 pence and then 100 markers is $39.05. So with this type of question, you put your answer in this box. You type it and then you put your answer in this box. Then you move on to the next question. So you can see that with this question, there are no options. You have to solve and then write your solution in the box provided. Now let's look at the last question, which is question 10. We are given a triangle, and this is a right angle triangle, right? But we are given more information. It says given that angle angle BAC is 90, and you can see by this symbol, it's a right angle triangle, so it's perpendicular. The length AB is perpendicular to the length AC, so the angle there is 90, and then angle ACB. So let's try to draw this. We know that this is 90, right? Let me clear this side from there. All right. So we know that this side is 90, and this is B, this is A, this is C. Now the question, we are given an information that angle ACB, so ACB, so the angle will be here, and that angle is 30 degrees. Then automatically we know that angles in a triangle sum up to 180, right? So if we know this angle to be 90, this one to be 30, then here is 60 degrees. In the GRE question, you do not have much time to do a lot of calculations, so sometimes we look for shortcuts in getting our right answers. Now this is a 90, 60, 30 triangle, and there is a rule for this, the 90, 60 triangle. Now the shortest side, when you have a 90, 60, 30 triangle, I'm giving you the rules involved. The shortest side, we call it x, or we term it as x, right? And the shortest side will definitely be this side. For the angle, the side that is opposite the 30 degrees is the shortest side, and always we label it as x, right? And then the hypotenuse, we label it as 2x, or 2 multiplying x. Then the adjacent, or the side that is opposite to the 60 degrees angle, we label it as x root of 3. So with these three sides, you will be able to find whatever you are looking for. Now when you look at the question, you can see that the length of AB is actually 6. This side is 6. From the question, we have it here. You can see 6 here. So it tells us that from A to B is 6, and A to B is what we have labeled as x, which simply means that our x is actually equal to 6. So x is equal to 6. Now if we know x to be equal to 6, then we can find our hypotenuse, because the hypotenuse is 2x, which is 2 times what? 6, and that is 12. So our hypotenuse becomes 12. Then the adjacent now becomes 6 root 3. So when you know this rule, it becomes easy to find the length of the other side. So put this in your head, that when it comes to the 90, 60, 30 triangle, the shortest side, which is the angle that is opposite, the side that is opposite to the 30 degrees angle, is the shortest side, and mostly we label that as x. The hypotenuse is 2 times x, and then the side that is opposite to the 60 degrees is labeled as x root of 3. When you know this information and you know one side, you can find the other side. So for this, the question says that what is the area of triangle ABC as shown above? So you remember the area of a triangle, which is given as half times the base times the height. Now what is the base of the triangle? It is AC. So in this triangle, we have our base to be the distance of AC from A to C, and then the height is the distance from A to B. And we have already found this length. Now AC is 6 root 3, and then AB is just 6. Now 2 goes into A sub 1 goes into 6. How many times? 3. So we have 6 root 3 multiplying 3, and this is 18 root 3. Clearly from the options you can see that D is our correct answer, which is 18 root 3. This is how we find the area of a triangle, a right angled triangle, which is half times base times height. So when you get to know the side, the base, and then the height of the triangle, you'll be able to calculate for the area. And this is how we do it. So in this tutorial section, we only answered 10 questions. So these are sample questions from the GRE quantitative test that I decided to go through with you. And I believe that today's lesson has been a fruitful one, right? If you are new to the GRE, this video is good for you. If you are going to write the GRE again, of course, this video is also good for you, because in the GRE, one of the takeaways is that you don't want to spend much time solving the questions. So you need to have or get some basic shortcut in getting the right answers, right? Now, a piece of advice I'll give to you is that if you are solving a particular question and then you are stuck, you are not able to get an answer to that question, quickly move on to the next question. Do not waste more than 2 minutes solving one particular question in the quantitative section. If you attack it or you try it and then you don't get the answer, move on to the next question. Make sure that you're able to solve all the ones you can do in the sections. Then if there is time, you come back to the ones you couldn't do. Because if you waste time on one particular question, sometimes there are some other questions ahead of you that you can answer them easily. But because you are wasting time on one particular question, you might not be able to get there. Mind you, the time is very limited. All right, so we have ended today's tutorials, and then I believe that this session today's session was really great. So what you have to do is make sure that you share, and then you subscribe to this particular YouTube channel. I'll make more videos of the GRE Quantitative Section. In fact, this is part 1. I'll bring you a video on part 2, and we will look at other different questions as well. All right, have a nice day.